Okay, when we left off last week, we had talked about operations with all of our different types of numbers. The one thing that we had run out of time to get to was our problems that look like this. Come on. Something like that, where there's more than one operation that needs to be done. Most of the time, you are going to have some sort of a situation, a story problem, a word problem, or some sort of context that's happening in. And that's going to tell you what has to happen first. If we don't have any of that, if we just have a list of numbers and operations like this, in order to make sure that two people look at that and do the same thing, get the same answer, we define something called the order of operations. Now, a lot of people think of the order of operations as a set of steps, and that's not quite accurate. What the order of operations really is it's levels of priority. So things at a higher level have to happen before things at a lower level. So the highest level of priority is something called enclosing symbols. Many of us have been taught parentheses is at highest level, and that is one of our types of enclosing symbols. In fact, there are several types of parentheses. You have the square brackets, the squiggly brackets, and other types of brackets like that. This book sometimes uses those to signify if there's multiple sets of parentheses, so you know which one they're paired with. You won't necessarily have that. One of the things you have to learn how to do is figure out which two parentheses go together in a pair. But there are other types of enclosing symbols other than those parentheses and brackets. We'll see some of them today. The second step, second level of priority, is something called exponents. Exponents is actually a pair of operations, just like addition and subtraction is a pair, and multiplication and division go together. Exponents actually includes two operations. That's powers and roots. Our next, or third level of priority, we get down to the pair of operations of multiplication and division. And finally, our last or lowest level of priority is addition and subtraction. So addition and subtraction can only happen to a number if there's nothing else happening to it that has a higher priority. So back to our original question over here. We don't have any enclosing symbols. We don't have any exponents, no powers or roots. So we would be down to multiplication and division. We have the 3 times 4. So we need to combine the 3 and 4, 3 times 4 to make 12, and the rest of the problem stays the same. Now from there, all that's left is addition and subtraction. A lot of people get confused thinking addition comes first. It does not. Addition and subtraction are on the same level of priority. So when we have two things on the same level, then we do work left to right, just like reading a book. So over here, going left to right, we have the 17 minus 12 first, which is 5. We still have the plus 5 here. So then we end up with 5 plus 5, which is 10. So it all comes out to be a 10. Let's look at an example that's a little bit more difficult. Oh, this one's not so bad. It's a little more difficult. It looks kind of long, but as long as we follow our levels, go through it step by step, it's not so bad. The worst part of the whole problem like this is having to rewrite the thing over and over. So as we look at this, first thing is enclosing symbols. Now there's several parentheses here, so we work left to right. And going left to right, this is the first one we see. So we need to find its other end. Is this one it? No, that one's facing the wrong way. This one's facing the right way, but that has to go with this one. So we go all the way down here. There's the other end of that parentheses. So we're going to start working inside that parentheses. We're just going to say inside the blue box. Inside there, however, our order of operations still applies. So we go back up to the highest level. Are there any other enclosing symbols? Yes. We have another set of parentheses here. So we go inside that set. So inside the green box now. Inside there, our order of operations still applies. Are there any other enclosing symbols? No. Exponents? No. So we're down to multiplication and division. 36 divided by 9 is 4. So we take out the 36 divided by 9 and replace it with 4. Everything else in the whole problem has to stay exactly the same. So now, we're still inside that parentheses, still inside the green box. The only thing that's left to do is subtract. 8 minus 4, which is 4. So we take out the 8 minus 4 and replace it with 4. Now we've reduced the parentheses to a single number. We don't need the parentheses anymore, so we can take that set out. This set here is gone. Again, everything else in the problem stays exactly the same. So now we're back out to the larger set of parentheses, that blue box, if you will. Inside there, we still have to go through our levels of priority. Are there other enclosing symbols? No. Exponents? Yes, we have 3 squared, which is 9. Perfect. So we take out the 3 squared and replace it with 9. Again, everything else stays exactly the same. Now we're still inside that set of parentheses. Any other exponents? No, so we can move down a level. Multiplication and division. Yes, we have 5 times 9, which is 45. So replace that. No more multiplication or division inside the parentheses. So we go down to addition and subtraction. And there's more than one, so we're going to go left to right again. 11 minus 4 is 7. All that's left to do inside there is 7 plus 45 is 52. Now that parentheses is down to a single number again, so just like before, I can get rid of the parentheses. However, there's something I have to do this time when I remove the parentheses. What is it? Yeah, the 3 here was outside the parentheses with no operation between them. That implies it was multiplying. So when we take out the parentheses, we do have to put in a multiplication symbol there so we don't lose track of it. Now we're done with that parentheses. We got to go back up our levels of priority. Are there any other enclosing symbols? No. Exponents? No. Multiplication, division? Yes. So 3 times 52 do 156. Very good. No more multiplication and division, so we're down to addition and subtraction. We'll go left to right. 7 plus 156, 163. And then, of course, we have minus 7, which is 156 again. So 156 is what we get out of that. It's a lot of steps, and it's a lot of writing to write it out every time. But that usually is the best way to do it. Let's look at something a little different than that one. So when we look at a problem like this, the key to understanding it is figuring out what this line across here means. Okay, division. A lot of people say division. It's a fraction bar, and it does mean divide, but it's also an enclosing symbol. It separates part of the problem from the rest. So it's telling us that we have to do everything on top first. Then we have to do everything on bottom. Then we're going to divide them. So we start out on top. I'm going to write it off to the side here so we've got room to do it. What would we do first there? The exponent. 3 squared is 9. Next would be multiplying. 7 times 9, 63. And finally, 63 plus 9 is 72. So the top becomes 72. On bottom, what do we have to do first? Oh, yep, enclosing symbols. I almost screwed up there. Yes, 3 plus 4, which is 7. Now that reduces what's in the parentheses to a single number. We get rid of them. We have to remember to put in the multiplication. Good. Now what's next? Exponents. The 7 squared is 49. What's next? Multiply. 6 times 7 is 42. And then left to right. Adding and subtracting is all that's left. So 49 minus 42 is 7. 7 plus 1 is 8. Good. So the bottom is 8. Now we have to divide. 72 divided by 8 is 9. Not terrible. Now, on a test, if you were going to, remember the first test that's coming up, you do have to do part of the test without the calculator. At least you have to show your work on each problem on that test. You can go back and double check it with the calculator. And I'm guessing after this first test, if you have to do anything with order of operations, you're going to use the calculator. A problem like this one up here, if you punch it in exactly how it appears, your calculator actually does do the order of operations. So if you were to punch it in, with, just as that is there, let's see here, 7 plus 3. Some of your calculators you have to put in times before you put in the parentheses. Some of them you do not. 11 minus parentheses 8 minus 36 divided by 9. Close the parentheses. Plus 5 times 3 squared. Close parentheses. Minus 7. It does spit out the 156. So if it's in a single line like that, you just have to enter it in the calculator the way it appears. This last example, however, it's not in a single line, so it's a lot trickier to enter it in the calculator. You can enter it in the calculator so it'll do it in one step. It's just kind of tough to do. So what I recommend you would do is to type the top into the calculator first. And the calculator will do everything we did over here and give you the 72. So you write that down. Then type in the bottom, which will do everything we did here to give you the 8, and then divide the numbers. It saves a lot of mistakes. You can enter it in if you put parentheses in all the right places, but I see way too many mistakes in people trying to do that. One more example I want to show you, then we'll move on. Yes, you can use your notes and books on all the tests. It's just on the first 2 pages of this test. In fact, I think I've got on there where you can start using the calculator and whatever. The first 2 pages, you have to show your work. So you can use your calculator to like combine numbers. If you have 7 times 9 and you're not sure, you can use the calculator for that. But you still have to show all the steps and the multiplication and subtraction and stuff. Okay, so let's show you something like this. So this one here has a couple things we haven't dealt with yet. The first one is this symbol here, which is the square root. The square root is part of the exponents. It's a root. But in this case, it is also serving as an enclosing symbol. It is separating the part that's inside of the radical from the rest of the problem. So we have to do all that stuff inside there first. So inside the root, what do we have to do first? The power. 3 squared is 9. What's next in there? 7 times 9 is 63. And then 1 plus 63, 64. Now, just like with the parentheses, we've reduced what's inside the enclosing symbol, in this case, what's inside the root, to a single number. So I can get rid of the enclosing symbol. Now, unlike the parentheses, where we just took out the parentheses, here we actually have to do something when we remove the root. We have to take the square root of 64, which is 8. On your calculators, I would never make you do a root without a calculator unless it was one like 25 or something that you should know. On your calculators, most of your calculators, your square root symbol involves a couple of steps. It's usually not a regular key on the calculator, it's a second function. And usually if you find your x squared key, like this one right here, if you find your x squared key, it's the second function above it. You see the little square root symbol above it? So to enter a square root on most of your calculators, you have to hit second or shift, depending on the type of calculator. Then that square root key, and then you would type in the 64 and hit equals. Tells you the 8. Okay, so that does become 64, or does become 8 after we square root the 64. Now, just like with the parentheses, we had the 3 outside the root. That's implied to be multiplication. So it's 3 times the 8 now. And that is our next step. 3 times 8 is 24. And finally, 7 plus 24 is 31. Any questions? Okay. So that's the last couple of things we had to wrap up from last week. So on to our new stuff. So a couple of the big things we want to work on this week. We want to look on percent. I'll get a new page here. To understand percents, the first step is to understand the word itself. Percent is actually two words. Per, if you think of miles per hour or miles per gallon, it's for each or out of. And then cent. You can think of years in a century or cents in a dollar. That means 100. So percent literally means out of 100. So if you have 36%, that literally means 36 over 100, out of 100. So it's a fraction or a ratio. In fact, it's that simple to convert a percent into a fraction. We just put it over 100 like that. Now, we would not leave it as 36 over 100 because it can be reduced. What can both of them be divided by? 4. You could divide by 2 if you wanted to, and just divide again. If we divide 36 divided by 4 is 9. 100 divided by 4? 25. So that reduces to 9/25. If I have 65%, that would become what as we converted it to a fraction? 65 over 100, and we divide by 5. Perfect. 65 divided by 5 is 13. 100 divided by 5 is 20. So 13/20. If you haven't learned by now, I always make it worse. It's part of my job. 240%. Of course, 240% is 240 over 100. Yeah, percent is always over 100, no matter how many digits we started out with. Now, there's two things you'll notice here. One, you'll notice it can be reduced, but two, you'll notice it's an improper fraction. The numerator is bigger than the denominator. I would usually reduce it now while we have 100 in the denominator because it's usually easier for me to divide out 100. How many times does 100 go into 240? Twice. How many would be left over? The 40. So we split it into a mixed number. Now we still need to reduce the fraction, the 40 over 100. What's that? Divide by 10. They both end in 0, so we can divide by 10. 40 divided by 10 is 4. 100 divided by 10? 10. Are we done there? No, we can still divide by 2. Perfect. 4 divided by 2? 2. 10 divided by 2? 5. Are we done now? What do we still need? What one little thing do we still need to do? Make sure you keep the whole number there, the 2. That's the single biggest mistake I see people make is forget the whole number once they start reducing. Okay. Yeah. You could have just, instead of dividing by 10, you could have just crossed off a 0 and had 4 over 10 and then gone from there. Or you could have even done it here, crossed off that and did 24 over 10. That works just fine too. I mean, you may have something like 364%. So that's going to be 364 over 100. As a mixed number, what's that going to be? Perfect. 100 goes in there 3 times, with 64 left over. So 3 and 64 over 100. Now we still have to reduce that fraction. Those both can be divided by 2, I heard. 64 divided by 2? 32, and 100 divided by 2? 50. We can still divide by 2. 32 divided by 2 is 16. 50 divided by 2 is 25. Don't forget the 3. What about 37.5%? Well, it's still, 37.5 over 100. Now, we don't like having fraction or decimals within our fractions. So to get rid of that decimal, just like when we divide by a decimal, we move the decimal point over, we're really multiplying by 10. Same here. I need to move that decimal point over one spot. I would multiply by 10 to do it. If I'm, bless you, multiply the numerator by 10, I must multiply the denominator by 10. So this becomes 375 over 1,000. Both of those can now be reduced by 5. 375 divided by 5, 75. 1,000 divided by 5 is 200. What's next? Divide by 5 again would work. That would give us 15 over 40. We can still divide by 5. Get 3 over 8. Nope, that's gone. When we multiplied by 10 over 10 here. So that's like multiplying by 1. So we changed the appearance, but we didn't change the value. So we changed the appearance so the decimal point's gone, but it's still the same value. So we don't have to do anything more with that decimal point. It's gone. Well, that's a very good question. Will it always be by 10? This one will answer that question. So 56.25% is 56.25 over 100. To get rid of the decimal there, what would we have to multiply by? 100. Why 100 instead of 10? Because it's 2 decimal places we have to go. Good. So that's 5,625 over 10,000. Now, of course, here the reducing is going to be fun. There may be a little sarcasm there. What do you guys see that we can reduce that by? 5? I heard somebody say 25. Let's try 25. So if we go by 25, $5,625 divided by 25 is 225. 10,000 divided by 25 is 400. So yes, we can divide both of them by 25. How about now? We can still divide by 25 again. 225 divided by 25 is 9. 400 divided by 25 is 16. Good. So we get 9/16. Nope, 16 doesn't divide by 3. That's it. Did I show you guys last week the shortcut for telling if a number can divide by 3? No? If you had 1 plus 6 is 7, that doesn't divide by 3, so the number doesn't divide by 3. That only works with 3s and 9s. But well, how about this one? 36 2/3%. Well, if we try to turn that into a decimal, we get 36.66666666666. So that's not going to work. But we can just do 36 2/3 over 100. Now at this point, there are actually a couple of different options. Somehow I feel like my purpose for the day is fulfilled when students start groaning in the back of the classroom. Something about the nature of a math teacher, I guess. There are a couple of options for what we can do here. The first option would be to eliminate the fraction, eliminate the denominator. And what I mean by that is there's only one denominator here in this whole problem, and that is the 3. If I multiply by 3, it'll eliminate that denominator. So I have to multiply both the top and the bottom here by 3. So the easy part, of course, is 100 times 3 is 300. Well, okay, you're right. I should be careful here. There is actually a fraction within a fraction here. The 100 is the denominator of the big fraction. But within each of them, there's only one fraction within. There's no fraction in the denominator. There's only the fraction in the numerator. So in the numerator, the only denominator within the fraction we have is the 3. You're right, I worded that very poorly. So the only fraction we need to get rid of is the 2/3 here. And that denominator is the 3, so we're going to multiply by it. So we've got 36 and 2/3 times 3. So that's going to become 3 over 1. 36 and 2/3, 36 times 3 is 108, plus 2 is 110. And by design here, the 3's will cross cancel out. So all that's left there is 110. That gives us 110 in our numerator. Now that's over 300. Yeah, we divide by 10 or cancel out the 0, however you want to look at it. It's 11 over 30. Now I said there was 2 possibilities here. The second possibility, when you look at that 36 and 2/3 over 100, is to just divide it. But you can't divide it by decimal or anything like that. You have to divide it as a fraction. So 36 and 2/3, of course, we'll treat this as 100 over 1, right? 36 and 2/3 has to be turned into an improper fraction. We just did that over here. That's 110 over 3. Anybody have any questions on where we got the 110 over 3? It was 36 times the denominator of 3 is 108, plus the numerator of 2. Now, instead of dividing by 100 over 1, we're going to multiply by the reciprocal, which is 1 over 100. If I wanted to here, I can cross cancel. Both 110 and 100 can divide by 10. Gives me 11 and 10. 11 times 1 is 11. 3 times 10 is 30. We get the same answer either way. I think this way is easier, but some people get confused about how do we find what we need to multiply by. So this is probably more straightforward to just divide it out as fractions. I'm going to have you try one in your notes here. 18 1/3%. Convert that into a fraction. I'll give you a couple minutes, and then we'll talk about it. Let's take a look and see how you did. So we have 18 1/3%, which is going to be 18 1/3 over 100. Do you guys have a preference on how I proceed? Do you want me to multiply by 3, or do you want me to just divide it out? Multiply. Let's do it both ways. Now the first question is, how do I know to multiply by 3? Yeah, we've got a denominator of 3 here within our fractions. I'll get rid of that thirds. By 4, yep. If it was 1/7, multiply by 7, yep. Perfect. So 18 1/3 times 3 is 55. 100 times 3, 300. Of course, that reduces by 5. So 11 over 60. Did you do? Oh, sure, you got 55 over 3. Yep. Yeah, so you divide it by 100 like this. So this becomes 55 over 3 times 1 over 100, like that. Yeah. Okay, perfect. Sure. That works too. That's just dividing it out like the second way we did it. Yeah, I know sometimes showing it multiple ways can be confusing. Just block out the second way if the first one makes sense. Yeah. Well, are you blurring the two things together? Yeah. Well, that would be right here. That would be 3 over 1 times this. Technically, this here is 55 over 3 times 3 over 1. I just didn't write it out. I just gave the answer of 55. Yeah. Yeah. Okay. Oh, I totally understand. It's a this is my last class of the week, and I'm heading camping. So my little hamster is sitting in a lawn chair by a campfire already. My last class told me they felt like their little hamster was roasting over the campfire. So I don't know what that says about me, but well. Our next step now, we want to convert our percents into decimals. So we already said 38% meant 38 over 100. To turn a fraction into a decimal, we just divide it out. So that would be 38 divided by 100, which of course is 0.38. Anytime we divide by 100, what does it do to our number? That moves the decimal point over 2 spots to the left. And since when we're dealing with percents, it's always out of 100. We're always going to be dividing by 100. That's all that's going to happen. It's always going to move that decimal point 2 places to the left. So 65% is 65 over 100, or 65 divided by 100, which is 0.65. Moving that decimal point over 2 spots again. So if I give you 91%, what would that be as a decimal? 0.91. How about 40%? 0.40, or you could do just 0.4. 7%. Perfect. 0.07. You got to be careful with that one because it's only one digit. You have to add the 0 in front of it. 3.2% is a decimal. 0.032. Good. 180% is a decimal. 1.8. Good. How about 374.6% is a decimal? Perfect. 3.746. Sure. That makes sense. Yeah, just drop the decimal point and go with it. How about 1/4% is a decimal? Now stop and be careful here. A lot of people are going to jump in to say 0.25. Not 0, but that's okay. That one's a very common one. Remember, 1/4 is 0.25, but that would still be a percent. So you still have to move it 2 spots to get the 0.0025. When we calculate with percents, one thing I kind of preach a little bit is benchmarks. One benchmark is 1%. What's 1% as a decimal? 0.01. 1/4%, of course, is smaller than 1. So 1/4 has to be smaller than 0.01 when we turn it into the decimal. Yeah, yeah, that's fine. Okay, that's a very good question. Like here where it's 0.07, if we just did 0.07, would it be wrong? For my class, no. But for those of you that are going into the ADN program, they do require that 0 there. The reason being is, now I made that decimal point very obvious that that's 0.8 milligrams. But if you have something like this, is that 0.8 milligrams or is that just a stray mark and that's 8 milligrams? Having that 0 up front, well, there's no reason for that 0 there unless there's that decimal point. So that 0 up front emphasizes that there's a decimal point. Now, something like 0.07, that one to me seems obvious that there's a decimal point there, but they do still want that 0 there. Otherwise, in the ADN program, they will mark that wrong. Like you can read a doctor's writing anyway, right? So, a decimal going back into a percent. If I have something like 0.35, that, of course, means as a decimal, that means out of 1. Well, a percent means out of 100. So if I'm converting this, if I think of equivalent fractions, turn the 1 into 100, I'd have to multiply by 100. So I'd have to do the same in the numerator. 0.35 times 100 is 35. So that's 35 out of 100, or 35%. Since we're always going to be multiplying by 100, the decimal point is always going to be moving 2 spots to the right. So yeah, I wouldn't make you write that out. I would accept it if you just move the decimal point. So if I have 0.91, what's that going to become as a percent? 91. 0.2, what's that going to become as a percent? 20. Very good. Helps when I put my percent symbol there. Yeah, you have to move it 2 spots, so you have to add that 0 on the end. 3.7, what's that going to become as a percent? 370%. 0.094. 9.4%. It moves just 2 spots. Any questions? The last step then for converting is taking a fraction and turning it back into a percent. Let's start with one you all know. What is 3/4 as a percent? 75%. If you didn't know that that was 75%, there are a couple of options. One option is turn the fraction 3/4 into a decimal. 3 divided by 4, 0.75, and then move the decimal point the 2 spots to make it 75%. The other option is to do just like we did up above here. 3/4 can be thought of as 3 out of 4. A percent is always out of 100. So to convert that, there's a couple of ways we can go about that. One, we can think of equivalent fractions. What would you multiply 4 by to turn it into 100? 25. So you have to multiply 3 by 25. Gives you 75. However, we could have something like 5/8. 5 out of 8 equals how much out of 100? Well, looking at this, it's a little tricky to figure out what do you multiply an 8 by to turn it into 100? Well, if I don't know what it is, to figure it out, I would just work backwards. What's 100 divided by 8? Well, that's 12.5, right? What am I going to do then to my 5? I'm going to multiply by the 12.5. Because what I did down here is I had multiplied the 8 by 12.5 to make 100. I have to multiply by that 12.5 up here to make 62.5 out of 100, or 62.5%. What I just did here happens often enough that they've created a shortcut for it. What we did was we took the 100 here, divided by the 8, then we multiplied the 5 by it. What they've done to kind of, the gimmick they've come up with, or the shortcut, they call it cross multiply and divide. We're going to take this number here, and we're going to multiply it by this number divided by that number. So they're going to multiply the two numbers that are on the diagonal. 5 times 100 is 500. And then divide by the other number that's on the other diagonal by itself. Dividing by 8 is 62.5. So let's do some examples of that. Like 3/5. If I want to turn that into 100, what two numbers are on the diagonal with each other? 3 and 100. 3 times 100 is 300. Then we're going to divide by the 5. Gives us 60. So 60 over 100, or 60%. We might have 2 sevenths. Make that into a percent. How much out of 100? What do we multiply? 2 times 100 is 200. Divided by 7, which is 28.571429 approximately. Or if we round it off to 100th of a percent, 28.57. Remember I told you last week that math is all about patterns? Once you see those patterns, the calculations become really easy. I could go on for probably 40 or 50 decimal places. Good question. If it's not specified, we'll go to 2 decimal places. Usually the problem will tell you, or the instructions will tell you, but if it's not, 2 decimal places. Okay, it is time for our break, so let's go ahead and do that. So here we go. So now that we know how to convert our percents, we need to do some calculations with them. And we'll start out with the basics today of, just some simple little phrase problems. But I want to start out with what I mentioned at the end of last hour, and that's that thing of benchmarks. Benchmarks are a very simple tool, and they're useful in a couple of ways. One, helps us estimate to see, so we can check ahead of time to see if our answer is reasonable. Second, we can actually do some relatively complex calculations without having to use a calculator. What do I mean by benchmarks? Well, let's take a look. Let's say we have a number 2,340. If I want to find 10% of that, well, most of us already know this shortcut, but let's step through it. 10% is 10 out of 100 as a fraction, which would reduce to 1/10. 1/10 dividing by 10, what does that do to the number? Moves it over one spot, right? So 10% of 2,340 is just going to be 234. One percent is 1 out of 100, or just dividing by 100. And we've already gone over, when we divide by 100, what does it do? Moves it 2 spots to the left. So 1% of 2,340 would be 23.4. Why is this so useful? Well, let's say I'm asked to find 12% of 2,340. First of all, I can do an estimate here. 10% is 234. 12% slightly more than that, right? So I know my answer better be something slightly more than 234. But I can actually find it exactly. 12% is 10% plus 1% plus 1%, right? 10 plus 1 plus 1 is 12. 10% is 234. 1% is 23.4. And of course, another 1%, so another 23.4. And we can just simply add those up. So it's 280.8 is 12% of 2,340. Now this does take a little bit of time, and this was pretty simple. If it was something like 52 or things like that, it would be a little more complex. But if you're caught needing to make a percent calculation and you don't have a calculator, this does work. I mean, there are other benchmarks out there, like 50% of 2,340. Well, 50% is just going to be half. So that's 1,170, right? That one's a little tougher to do, but you could do it. So if I had to find, 52%, or let's say 49%. Of 2,340. That one I could actually look at as 50%, which is 1,170, and subtract 1%. Subtract 23.4. And again, it's a little bit of work, but if we're caught without that calculator again, we can, a little bit of paperwork, we can find that percentage exactly. So if we do have the calculator available, how do we go about calculating those percents? And then, like I said before, everybody sees different patterns. For some people, 49% makes more sense the way I just did it, of 50 minus 1. Others might want to do it as 10 plus 10 plus 10 plus 10 plus 9 ones. But it's a tool out there. Like I said, it's a little long and tedious, but it's a tool that's there. If you have to do them by hand, it's a way to get it done. For the most part, for me, it's a way of estimating your answer. So if you mess up a key on the calculator, you can catch it. So what if I ask, what is 35% of 80? Well, we saw when we were converting those fractions, we did that cross multiply and divide. Let's use that same tool. That tool, by the way, is called a proportion. And a proportion is just setting basically two fractions. It's technically two ratios equal to each other. So the percent, 35%, we know is 35 over 100. And that's always where we're going to start. The 35, the number that's from the percent itself, represents a portion of interest. It's a piece that we're kind of zeroing in on. The 100 represents the whole thing, or a starting amount or initial amount. Often referred to as the base or the baseline. So now on the other side, we have to match numbers up with the 35 and 100. One of the keys to using a proportion is that relationship, that things match up. So 80 here, is that the piece we're focusing in on, or is that the whole thing? That's the whole thing. We know that because of 80, you can think of that as saying out of 80. It implies that 80 has to go on the bottom. Now to find that missing number, we can use that tool we talked about, cross, multiply, and divide. 35 times 80 is 2,800. And then we divide by the 100. which is 28. So 28 is 35% of 80. There are a lot of different ways of wording this. Instead of saying what is 35% of 80, we could ask it like this. Blank is 70% of 30. So again, we're going to start with the percent. 70% will be 70 over 100. On the other side, we have the missing number, and we have the 30. Is the 30 the whole thing or the piece we're zeroing in on? It's the whole thing. So again, we're going to cross multiply and divide. We're going to multiply 70 times 30. 2100. Divided by 100 is 21. So 21 is 70% of 30. Kind of like this one? 42. Great minds think alike. Huh? 42 is 60% of blank. We start with the percent again. 60% is 60 out of 100. We always start with that percent because we know it's out of 100. 42 is on top. 42 is 60%. So the 42 matches up with the 60. And we're missing the number on bottom. Now things are in a different spot, but it's still cross multiply and divide. What two numbers are on diagonal with each other right now? The 42 and 100. Multiply us to make 4,200. What's that? Okay. What you could do if you put X down here is there is a process that's called just cross multiplying. And it would look like this. If you put X down there, you would cross multiply this way. 60 times X is 60X. You'd multiply this way. 100 times 42 is 4,200, and they have to be equal. So 60X equals 4,200. Now you divide by 60 to solve. To do the equation? Okay. So dividing by, so an equation like this, to solve it, you would divide by 60. X equals 70. If it's in this simple little sentence problem like this, that is true. A lot of places will teach, a lot of textbooks teach is over of. I avoid that a little bit because when you get into some of the word problems, that gets confusing because the word is appears in a lot of sentences and it doesn't necessarily mean it's the top number in that fraction. So you gotta be a little bit careful with that. So here, 40% of 90 is blank. So again, we start with the percent. 40% is 40 out of 100. Equals, we have the 90. Is the 90 the whole thing or the piece we're zeroing in on? It is the whole thing. Of 90, think of it as out of 90. So, because that's the way you guys said you think a little bit, let's put the X in there. So we're going to do 40 times 90, 3,600. Cross multiplying this way is 100 times X is 100X. So now, what's that? 36, perfect. Yeah, so 100X equals 360. And yes, we do divide by 100 to solve. So X does equal 36. Does that make more sense now? Okay. Oh, sure. Sure. So you're better off just doing 40 times 90 and dividing by the 100? Okay. 4, yeah. So we might have 90% of blank is 45. Where do we start? 90% is 90 over 100. 45 is on top. The of blank, assume that's out of blank, so the blank goes on bottom. So now if you want to put in the x and cross multiply and solve, you can. We're going to cross multiply here. 100 times 45 is 4,500. It would be 90x equals 4,500, or just divide by 90 is 50. So 90% of 50 is 45. So we have something like this. 32 is blank percent of 80. Well, I told you to always start with the percent. However, here we don't have the percent. We're just going to put blank over 100 or x over 100, yes. On the other side, we have the 32 and the 80. Which one goes on top? 32 over the 80. Yep, 100 times 32 is 3,200. So 40, you got it. So it's 40%. So blank percent of 70 is 14. Tell me what to do. X over 100 or blank over 100. 70 on bottom, 14 on top. So 14 over 70. Okay. 100 times 14 is 1,400. Divide by 70 will be 20. What if I tell you that blank percent of 60 is 84? Blank over 100. (84 over 60). It's confusing because you're used to the small number going on top over the big number, but think of 60 as being out of 60 implies the 60 has to go on bottom. The blank percent is 84, so the 84 has to go on top. Now, before I even calculate anything here, what do I know about this percent? It has to be bigger than 100 because the piece we're focusing on is bigger than the whole thing, so it's more than 100%. So 100 times 84 is 8,400. Bless you. Divided by 60 is 140, so that's 140%. Now, I like the proportion method. That's the way I do most of my calculations. There is another method out there. I know some of you don't like seeing extra methods, but there's something called the rate method. And this does come in a little bit when we do our dosage calculations because concentrations are calculated off a rate. And what a rate is, it is the decimal form of a percent. So 60% has a rate of 0.6. So this problem here, what is 35% of 80? Well, the rate for 35% is 0.35. We would solve this problem here by taking the 80 and multiplying by 0.35, which would give us 28. Now you might look at that and think that looks pretty easy. In fact, if we do the next one, 70%, the rate for 70% is, careful, just 0.7. Only 2 spots. 0.70, there we go. So we take the 30 times that 0.70 or 0.7, gives us 21. Same answer we had before. The problem comes when we get to this third one. 60%, its rate is 0.6, but we would not take 42 times 0.6. We would have to divide. Because what we have is not the whole thing, it's the piece. We're going the other direction. So the problem with the rate method is, to do it, you turn the percent into a decimal, but then you have to decide whether you have to multiply or divide by it. Where we will use rates a little bit in the dosage calculation unit, but where the rate method is really useful is only in this case where you're going to be multiplying by that decimal. In business and banking, you do interest calculations that way because you're always going to be multiplying the principal by the interest. In commissions and sales and stuff, you're always going to be multiplying your sales by your commission. So they'll use the rate method of percents for calculating those percents. Otherwise, any other method of any other type of percent problem, to me, it's way easier to use this proportion. The other thing I really like about the proportion is when we get into word problems, if we have something like MBT Corporation, that's just the height of my creativity for the day, estimates monthly profit. What's that? Oh, there you go. Thanks. MBT Corporation estimates monthly profit as 12% of gross sales. Find the gross sales for a month when profit is estimated at $27,600. Now, just like our simple sentence problems we had up there, we start with the percent. The percent in this problem is the 12%. So that's 12 over 100. Now, in a word problem, we said up above, the 12 represents the piece we're focusing in on, and the 100 represents the whole thing, or the starting amount. So here, what is usually it's easiest to pick out the 100. What is the whole thing here that we're looking at? Well, it would be the gross sales. So the 100%, the 100 represents gross sales. It really is a 100%. The 12 represents what? Monthly profit. That's a portion of the gross sales, right? So the monthly profit is that piece of the gross sales that the 12% is picking out for us. So now on the other side of this, we have the 27,600. Does that represent monthly profit or gross sales? profit is estimated at $27,600. So that has to go on top. So what we're looking for is on bottom here. So we will get back here. Do our cross multiplying to find that, whether you cross multiply and solve or cross multiply and divide. 100 times 27,600 is 2,760,000. We will end up dividing by the 12, which will be 23 million or 2.3 million. I'm getting 230 million. 230,000. Yeah, I'm getting 230,000. Got an extra zero somewhere. If you want to, yes. Actually, I gotta be careful. I spoke ahead of myself there. In this case, we can't because this is not, we're not multiplying the fractions, we're just multiplying the numbers. I could reduce within the fraction, the 12 and the 100. I could reduce that to 3 over 25, but I can't cross cancel like I can when I'm multiplying fractions. There will be some examples when we do dosage calculations where you can because you're multiplying, but here it's not multiplying, it's equal. Okay. Now I realize it's a little bit tedious to do this here where you map it out and write that out, but there are going to be problems where that saves us from making some serious mistakes. When we have these percent problems, there are usually a couple of pieces involved. Like here, 12% is monthly profit. There's another piece involved to it. There's the rest of it, the 88%, which goes to cover expenses or whatever. So we might have, after paying 30% in taxes, Sam takes home $2,100 for the month. How much did Sam pay in taxes? So we go to set up this problem. We've got the 30%. That's 30 over 100. The 30 represents what? Taxes. The 100 would represent the whole amount before taxes, right? So when we go to do the other side of this, how much did Sam pay in taxes? So that's what we're looking for, is the dollar amount of the taxes. The $2,100, does that represent what Sam earned before taxes? No, it doesn't. We don't have that amount. The $2,100 is after taxes. Well, there is another percent that's always looming in these percent problems. The technical word, and you don't need to know this word, is the complement. The complement means the other part. It's two pieces that add up to a total. Well, the total is represented by the 100%. The 30, we said, is the piece that we're focusing in on. Well, how much would be left over? 70, right? Out of 100%, we're focusing on 30s, the rest is 70%. So there is a 70% looming out there. The 100 still represents the before taxes. The 70 represents after taxes. So now The 2,100 is the after-tax amount. No, that won't come out. The reason is that that percent isn't based off the 2,100. It's based off of whatever that original amount was, and we don't know that original amount. So you do the 100 times 2,100 divided by 70, or you do your equation. This comes out to be $3,000. Now that's the before tax amount. Is that what we're looking for? No, we need to know how much she paid in taxes. So we still have to subtract. The before tax minus the after tax, $900 went to taxes. So these percent problems can get very complex. Now we're going to circle around in the next unit and we'll talk about percent problems more again later. To finish off this week, because we have to do it, you guys are all aware that our first test is next week, right? Yep, week 3 is our first test. It'll be in the first hour. Usually what I do is we'll start the test. Any of the locations, I'll have the test there by midweek. So if you want to come in earlier in the day on Friday to start it, you can. Here, I will be in this classroom, so just stop in and the next room is available. You can sit over there and take it if I'm in class. Otherwise, my hour before this class is always open, so you can come in early and start on the test. Usually at about 10:30 or 10:40, or not 10:30, about 11:30 or 11:40, there is a lecture in the second half of the class. So we will have new material at the second half of class next week. But anyway, our last little topic we need to finish off, our Unit 1, is Roman numerals. Unfortunately, in the medical fields, Roman numerals still get used in some of your dosage specifications, some of your concentrations. The Roman numeral system is very different from our numeral system. We are on Arabic numerals. In Arabic numbers, they go off of place values. In the Roman numeral system is what's called an additive system. They just add up as they go. First, let's look at the digits that are used. Now, I was always taught that you had to use capital letters for Roman numerals. That has since changed with modern typesets. Your book tends to use small letters for them. I use capital letters just so you know that that's an I and not a 1. I stands for 1. V stands for 5. 10 is X. 50 is L. 100 is C. You ever heard the term C note? Refers to a $100 bill. 500 is D. And 1,000 is M. Now, this is one that I actually didn't know until I started teaching this class. Come on, get back here. Oh, well, we'll just do the rest of the class in green. We only got 10 minutes. So the one that I didn't know until I started teaching this class is the Roman numeral for 1/2 is SS. Well, the only place I've ever seen it used is medicine. GRISS, that's 1.5 grains is what that stands for. So the way the Roman numeral system works is it's additive. So if I have, and larger digits come first. Larger amounts go first. So we would have like LXVII. What this is saying, L stands for 50. You got it. X stands for 10, V for 5, and 1 and 1 for the I's. That adds up to 67. Very good. Now, the larger amounts come first when they're adding. If, by chance, what they tried to avoid is repetitive. Like 3 is just I. For 4, rather than listing 4 I's out, they thought their numbers would get too long. So they did this, IV. When a smaller symbol before a larger one, that means it's subtracted from it. So whenever we look at a symbol, like up here, I just wrote down the numerical value for each symbol and add them together. But whenever we look at a symbol, we really should look at the one after it to make sure the symbol that comes after it is smaller. We might have D X C X I. The D is what value? 500. X is 10. The 500 is bigger than the 10, so I can just go ahead and put down the 500. Now, after the X, the C is what? 100. Now, since the C is bigger than the 10, 100 is bigger than 10, those two symbols work together and they're subtracted. What's 100 minus 10? 90. So now we have the X is 10, I is 1. So 10 is bigger than the 1, so we can just put down the 10. And then we have the 1. So that all adds up. Now that doesn't make sense, does it? 601. No. I shouldn't have had that X there. It wouldn't make sense to put that X after it. Why subtract 10 and then add 10 back in? I meant to have a V there, but like I said, the little hamster's in a camp chair by a fire right now. I'll try to do better in our last few minutes here. Let's do this one. CXLVIII. So C stands for 100. X is 10. So we can use the C. We can put down the 100. X is 10. L is 50. So what do we have to do with the X? We're going to subtract. 50 minus 10 is 40. So those are gone. We go to the V is 5. And of course, I is 1. So we can put down the 5. And then those are all 1s. That adds up to 148. Very good. Oh, let's do. Now, here's one that's always stumped me. Yes. If it was CLX. Yes, because this would be 100. This would be 50. So that means we're okay to bring down the 100. That's 50. This is 10. So we're okay to bring down the 50. That's 10. This is 5. So we're okay to bring down the 10. Yeah. Then you got to subtract. Yeah. You look at the second number. If it's smaller, then you can bring down the first one. Yeah. Now, here's the one that always stumped me. 46. I always wanted to do this. Now, don't write this down because it's going to be wrong. VLI, because that's 5, 50, and 1. 50 minus 5 is 45 plus 1, right? Makes sense. They don't do that. In Roman numerals, they only subtract from tens. What I mean by that is 10, 100, 1,000, 10,000, and so on. They don't subtract from the 5, the 50s, the 5s, the 50s, and I gotta be careful. They only subtract 10s. They only subtract 1s, 10s, 100s. They don't subtract 5s, 50s, and so on. So for 970, they would do 1,000, which is m minus 100, not minus 50. And then they would add the 50 and 2 10s. So the same up here. They would take the 50 and they would subtract 10 to get down to 40. Then they would add a 5 and a 1 to get 46. It's actually a little bit longer. It's less efficient. But for some reason, they only subtracted 10s. Realistically, you guys really don't need to convert from standard to Roman numerals. It's that Roman numerals to standard that's really the big calculation. What does that mean? Yeah. I is 1, x is 10, so that's smaller, so we have to subtract. That's 9, and SS is 1/2. SS, 3.5. Okay. I think you guys got her. So, what you actually have to do is relatively simple. So anyway, stuff that we need to do for homework. Page 23, 1 through 21, the odd. Page 36 through 37, 1 through 51, the odds. And page 39. I'm just going to say 1 through 12 because that's the Roman numeral conversions. I'd rather have you do all of those. Next week is our test. Remember, half of it you have to show your work. I'm not saying you can't use your calculator, but you still have to show all the steps by hand. So you can use the calculator for combining digits and double checking. Anybody have any questions? I'm here. I'll be here at 7:30, so anytime after 7:30. And it'll be at the other locations. I don't know what time the ITV office opens at each location, but it should be open by 8 or 8:30 at each location. So anytime after that, you might have to go to the ITV office at your location to get the test. Otherwise, they'll have it in a folder in the classroom. Usually have it in a folder at the front desk of the classroom or the front table. Okay, you guys have a great week. Yes, sir. You have